Okay, I guess we can start. Hello, everybody. Today, we have the pleasure to have Ying to discuss about this project in more details. So basically, the plan for today is that she will walk you through some code to get you familiarized with the framework overall and help you get started with this project, hopefully as quickly as possible. I'm very much looking forward to this. Thanks, Ying. Please start.
Thank you, Professor. Okay, just one update. I just pushed the source code to the GitHub, so you can get the code from here. But in the weekend, there will be some updates in the source code.
Yeah. So one maybe comment is that
let's go through it. Mm-hmm.
Maybe you should look at the updates in the infrastructure and the code from time to time and pull the latest push into this repository as often as possible, right? There might be some changes as we go on, but we try to also update you through Piazza as we do. Thanks.
Yes. Thanks, Professor.
And so, if you have any question throughout this presentation, please feel free to ask Ying. It is the time to make clear about everything.
Yeah, because the project will start next week. Actually, although we give you 3 weeks for each task, if you wanted to, come out some great results, actually it might take time, and it also takes time for you to do the experiment, to analyze the results, and it will take you some time to work on the reports. Yeah, ahead. Okay. Let's go through the requirements first. So basically, yeah, I have some updates in the here. Yes. So this bonus, basically we will consider additional credits for any new approaches that has not been implemented by Athena for task 1 and task 2. So you can dig deeper, you can Google, or if you found some interesting researches in this in this adversarial machine learning, you think it may be interesting or possible to implement to here, then you can try that. But don't spend too much time on trying new approaches, because the time limit. So you need to plan. It's a trade-off. Yeah. So for these new approaches, in your reports, you need to introduce the approach, and you need to cite the work, and you need to explain what it is, how it works, something like this. But you don't have to spend much space on this. You just explain concisely. Yeah, but concisely. That will be fine.
Yeah,
and you
add to this, basically you can think about like one paragraph description and a few equations, underlying equations that explain the work, right? And some snippets of the code, and that should be fine.
Yeah. So if you can provide the pseudocode of the algorithm with some explanation, that would be good. You need to, so whenever you implement some new approaches, try to compare the approach with the baselines we provided. So we will provide adversarial examples we generated as the baseline for you to compare with the adversarial examples you generated. And you can use the vanilla version of Athena and the PGD trained model. I will provide both of this to you as the baseline defenses. And you can also implement some other baseline defenses if you have time and you think it's interesting or wanted to compare with. So
that's a good point. Yeah. So besides the description, more importantly, I should emphasize that these insights, the results that you get, especially the explanation why you got this result, what it means, and the implication of that, and contrasting with the current approaches with Athena. If it is especially around the defense mechanism, if it is an alternative defense mechanism that you want to work, you want to compare with Athena as well as the other baseline, which is necessary, PGD-ADT. Even though, I mean, like any contrast would be useful to explain. These are what we are looking for, really. Inside, whether it is positive or negative, that doesn't matter. Whether it is successful or not successful doesn't really matter, but you're looking for some insight that you could explain. And there is one interesting question, thanks for asking. So the question is, could we use Athena Research Journal as a model for our report? Yes, definitely. We are going to also give you and publish actually the new version of this paper in maybe 2 or 3 weeks time. We'll send you basically updated version as soon as possible. And you can definitely use the current version as well as a kind of template. It's dense, you don't need to write as much, obviously, but you could definitely reuse if you want. For example, you could reuse part of the paper if you want. You can also think about the visualization that we put in there as a template for the kind of visualization you want to have. Okay, go ahead.
yes, thank you, Professor, for explaining this. We aim to look at the insights and from your results. So even if your approach doesn't work well, don't worry about this. Just try to find the reason why it doesn't work or something like that. Yeah. And yes, so we have talked about this, and I think maybe maybe task 2. I don't remember. Okay, so we have 4 options for task 2. Each of you, I mean, each group needs to claim which one you wanted to do on Piazza. Okay, so for this option 1 is the attacker's task. So in this option, you need to generate some adversarial examples in the context of the white box attack. So in this white box threat model, if you remember, the attacker will know everything about the Athena. So they know every single weak defenses and ensemble strategies we're using. So in this, in here we aim to, we have provided two type of optimization based approaches. So you can use the methods we provided, simply generate some weak defenses, generate some adversarial examples, something like that, and do the analysis. If you implement new approaches, we will consider bonus. Yeah, as always. So basically, if you are panic in coding or in this stuff, the easiest way is to, for example, for task 1, you just generate some adversarial examples we provided, and I mean using the method we provided, and choose this option 1 as your task 2, and generate AEs using these 2 attacks we provided. So basically, you can, if you can analyze your report, you can work. You have a great analyze in your results or something like that. You will still get full credit in your project. So, but if you want more challenges, you can choose other options. For example, this in this option 2, you need to train a model. In here we want a learning based ensemble strategy. So basically, you need to train a machine learning model. This model will take the output from weak defenses as its input, and produce the final result, final label for the for that X, for the input X. So this is here are some possible solutions I provided here. So the first one, you simply choose any model, any machine learning model, and train it. Just do something like this. So this is very simple. So the bonus will be 15%. And we have a previous study working on this adapted multi-column DNN. So if you implement this, you will get 20%. And here the knowledge from, so I just skimmed some paper. I think it's feasible, but I will continue. I will check some studies for you to work. Yes.
Your internet was not stable. Could you please repeat again for others? So
okay.
maybe explain the idea, right? What is the goal here? So you mentioned about learning based ensemble strategy. How a student needs to approach it, right?
Yeah. So in Athena currently we use some fixed strategy. So we simply use some majority voting or averaging the outputs from weak defenses. This is trivial. We wanted to see whether in here if we can learn, we can use a model, a DNA model, help us to. I think maybe it's like another classifier or Yes, if we can apply some deep learning approaches here, maybe we can get better results, because by simply use the majority voting, when the majority does well, inside from weak defenses.
So to maybe add a bit of explanation, and that is important, how you want to formulate it, right? So think about a very simple scenario, right? So each weak defense gives you some information, like think about a probability distribution, right? Um, and then your ensemble
Yes,
strategy
my
to
internet was.
wants to use these information, right? Wants to use this probability distribution information to generate the output, right? So at as abstract level, imagine that you have n different probability distribution, right? And then you want to use a weighted average of these probability distribution to generate one single final output probability distribution, right? So at the abstract level, this is a weighted average. And the task of learning ensemble strategy means that use supervised learning in your training set, from your training set, to come up with good weights, right? But to be clear, this is one out of several possible formulation about this ensemble strategy. I would suggest you to take a look at the literature about ensemble learning. Ensemble learning is a sub-part of machine learning, actually has been quite popular several years ago. And see what are the approaches there, and see whether you find some connection, interesting approaches that you may want to apply here. But first you need to fix your formulation about this learning based ensemble strategy, and everybody could formulate it differently, okay? It's up to you how you want to formulate it, and based on this formulation, then you can choose one of the existing approaches in ensemble methods and apply it there, and see whether you get a better result or not, right? No matter what. So if your attempt was either successful or unsuccessful, it's definitely worth reporting about your result. That doesn't matter. Don't think that you need to get better result. Even a negative result would be useful, and you will definitely get your extra point here if we see that you have attempted nicely and you wrote nicely about the result, whether positive or negative.
Yeah, even if your defense get like doesn't work well, I mean, maybe even worse than the undefended model, the target model, that's fine. If you can find the results and we can learn from that, you will get full credit. So don't worry about the result.
Yeah, and let's wait a little bit here. I want to ask a question. Can anybody, because this is important, I want to formulate it as a question here to see whether you really understood what we mean here. Can anybody explain what is the difference between a learning-based ensemble strategy and other ensemble strategy that you mentioned here in the paper? Any volunteer, or I should call on names?
Yeah, I think so. I think I could explain.
Yeah.
So with one ensemble strategy, or with the learning-based ensemble strategy, it's, as you said, it's so you take this, you try to learn this this set of weights whereby you would consider certain classifier or certain weak defenses, the classifiers that are the weak defenses. You would consider some of them more important than others in some way, based off of these weights. And the sum of these, you would use the sum of these weights through this learning process, which could be, there's a lot of different things, but like a neural network, deep learning, whatever, you can use any strategy there, I guess. And then the other ensemble strategies you discussed in the paper were all like predefined methods whereby you could consider the classifiers potentially voting. You could see which of them, I do believe they output some kind of a, do they output some kind of a probability, I assume?
Depends, right? So for example, some of them they do, but for example, majority voting, it doesn't, right? So majority voting, it looks at the highest probability class, and it decides based on a label by just like looking what are those most frequent classes, right?
Yes.
So it looks at frequency.
Okay. Right, because then you could look at which of them it believes to be more likely, and you could decide that you could choose the top two, most, the weak defenses which are the most certain, the top two weak defenses which believe they are the most certain about what the answer is, I guess. And then there's the other methods. I don't have the list up in front of me.
Yeah, that's a very good explanation. Thanks, Cody. Yeah, this is exactly what I wanted to hear, right? So the current ensemble strategy that we designed for Athena are fixed, right? Meaning that the strategy, no matter how many weak defenses we have, what would be the probability distribution? What would be the most probable classes? Whatever, it's fixed. So the strategy itself is fixed. But learning-based ensemble strategy, meaning that it really depends on particular situation. For example, could be dependent on the data. Part of it, obviously, part of it depends on the type of weak defenses and some other factors, right? So you want to learn some ensemble strategy based on whatever you have, right? What you have is like some weak defenses, some data, some probability distribution that you get, and also you have much more information actually down the line, like these neural networks, you have like these hidden layers. You can also use that, why not? You can come up with very interesting ensemble strategy based on learning, right? You could do clustering, for example, to find out what are the, you can, for example, one interesting idea could be create some cluster that maybe they're expert in one subset of the classes. For example, you can create one cluster that these weak defenses are really good to recover digit 1, 2, 3, right? The other clusters are expert and good in class 4, 5, 6, 7, 8, for example, right? Something like that. You could do clustering, you could do many interesting approaches, right? I'm very much looking forward to your formulation, okay? Because formulation matters. The kind of data you want to exploit for this learning problem, and also the result that you get, okay? So that would be fantastic. If you could show that you could came up, right? No matter how you did in other tasks, if you could show us how you came up with some learning-based ensemble strategy that performs actually better, right? Perform better than the existing fixed ensemble strategy on all attacks. No matter how you did it in other tasks, you get A, definitely. So try for it, specifically if you've come up with a nice formulation of this problem.
Yes, so the main purpose for this project is for your creativity. Okay. Yeah, so you need to do some evaluation for all of your approaches. So for defenses, you need to evaluate the models. The model here, I mean the approaches you trained, and then the defense you created. So you need to evaluate models' effectiveness against these adversarial examples. You need to, since you have generate some adversarial examples in your task 1, you need to evaluate it using the adversarial examples you generated, and evaluate your model against the baseline adversarial example we provided. So you need to, yeah, so for each, here, did I mention that? Okay, I forgot to mention it here. So actually for each defenses or adversarial examples, we expected you to generate several variants if it's possible. For example, if you build ensemble defenses, you can vary your defense with, for example, with different size, ensemble size. For example, an ensemble consists of 3 weak defenses, an ensemble consists of 10 weak defenses, something like that. So in that case, you can compare the effectiveness of your approaches. You can check how the changes in size impact the effectiveness of these defenses, something like that. And we provide 2 baseline models. So you need to compare. So basically, you need to evaluate these 2 baseline models using the adversarial examples you generated and the baseline examples. So you can compare the effectiveness, whether your approaches beats these 2 or not, and then you can further investigate, seek the reason why or why not, something like that. So yeah, the option 3 is the probabilistic Athena. So currently in this the vanilla version of Athena, we build the weak defenses, just use some CNN model. So in this approach, you can try to build some probabilistic classifiers. For example, using this Bayesian neural network. Since the training may take time, so you can just train like around 10 to 20 weak defenses. It depends on, so yeah, depends. If you have more time, you can train more. But since you have at least 3 students, you can separate this work, right? Each of you will train like 3 models. It will take Since this is MNIST, I think it will take less than half day. You will get all the weak defenses. Yeah. So whenever you train a model, you need to train the model on the training data only. Don't train your model on the test data, because that will be a cheating. You will think maybe your model performs well, but actually that's because your model has seen the test data at the training phase. So just use training data at the training phase.
Yeah, that's a very good point. So by now you should already know about this, right? So you have one training set and one test set. You can definitely use part of your training set as held out data if you want. You are perfectly fine by doing that, but you should not touch your test set at all. And don't report any training accuracy. If you want, you can, but like testing accuracy or testing error rate, right, is what it matters. Training accuracy or training error rate doesn't matter at all. And training accuracy, and specifically the held out data accuracy, might be useful for your debugging. And especially if you have questions about something you want to debug and you want to discuss with Ying, maybe this training or held out data accuracy would be useful to look at it, but for your report, like just test accuracy or test error rate, what it matters.
Yeah, so the training loss or training accuracy may help. So for example, after when you train a model, after, for example, like 20 epochs, it doesn't converge or something like that. So those information will help you debugging maybe something wrong in your training. You need to tune the parameters, something like that. Yeah. So it doesn't help in the report. We don't care it at all.
Yeah, very good point. Yeah, and one other point I would like to add, even though like it is for this project, it is only necessary to do this stuff with MNIST. But if you have time and if you would like to get more points for this course and to catch more interest from us, try your whatever you have done with C400 as well, right? It's
C400 might require GPU.
Like not really. So if they have time, or maybe some of students might already have access to GPU. But definitely they can run it on CPU as well, given more time. But I mean, it is not really essential, but if you're looking for more interesting result, that's what I strongly suggest you to do.
Yes. Okay. So I just give you some baseline. When I evaluate just for the predict C400 on my CPU, on the CPU desktop. Let me check the hardware. I think it will take me around 2 or 3 hours to do the prediction. So so that's some baseline for you to compare. I mean, to consider whether or not you wanted to work on C400.
Yeah, that's a very good point. And to be clear, always you can vary these. For example, by focusing on the weak defenses you want to consider, right? Maybe you don't want to, for C400, maybe you want to decrease the weak defenses to 10, right? You can obviously do that. Maybe you want to decrease your training set to half of what you already have, what is already a standard of the training set in C400. You're perfectly fine to do so, as long as you do proper explainable intervention and changes and reflect it in your report. That's absolutely fine. Right?
Yeah. Then when you select the samples, you need to be careful, because there are 100 classes in C400. So there are, I think it's 60K or 50K in 50K training samples. So for each class, it only have 500 images. So when you select for you, I mean, if you wanted to select for the training data, I mean, use a smaller training set, you need to pick images from each of the 100 classes. If you simply randomly select some of them, maybe the training set will be biased, and the result may be different, or I'm not sure. Yeah. You need to be careful to sampling from the training data and the test data. So that's just some tips. Yeah, so for here, you just, maybe you need to try some Bayesian neural network for this task. You just need to train the weak defenses, and then build the ensemble. You can simply use the majority voting and average output strategies. And then, as usual, you need to, so here, build several variants. So here you can try different strategies, for example, majority voting or adversarial outputs, and various ensemble sizes. And then you do the evaluation, you might get some curves, looks like this. For example, if you build the variants with different sizes, you can see here when the number of weak defenses increased, you might get the effectiveness will be improved. So the error rate will drop. But we're not sure yet, because this is a different type of model. So so the option for task 2 is the hybrid ensemble. So here, the hybrid ensemble here, we mentioned, we mean here is this ensemble was built on different type of models, because in the vanilla version of Athena, we built the ensemble using only on CNN models. So here we will provide SVM models and CNN models here. Then you can, for example, you don't have to, then you will have a pool size of 142 models. You don't have to build this, I mean, an ensemble consists of 140 weak defenses. That will be too large. I mean, because you need to load 140 weak defenses in on your desktop, maybe it will be out of memory or something like that. You can find some strategy to select a subset from this from this pool, and use this subset to build an ensemble. So you can use any strategies, for example, some greedy search based on some metrics. For example, this metrics maybe can be some entropy or ensemble diversities, or some based on some KL diverge or doing something like that. You just try by all means. Yeah, if you can find some other interesting approaches that can help you automatically select a subset from the pool, you can also try that. Okay, so here, because this is a defense, you will still need to do some evaluation. Yeah, so task 3 will be much easier, maybe. So after you, all of you submit your task 1 and task 2, I will start a script to run the cross evaluation, and it may take me 1 week to do that. And after I get the results, I will publish this evaluation results, so we can compare the AEs you generated, the defenses you built. We can see the results. And after, I also provide some experiment results. For example, the predictions of each defenses on each AEs. So you may do some further analysis based on these results, and trying to see whether there are some insights we can get from here. So basically, for task 3, just the analysis and the paperwork. Yeah. So because this is the final task, you need to, yeah, trying to find some reason, try to analysis why or why not your approach. For example, team 2, they generate some adversarial examples in the context of white box threat model, and team 3, they built a defense, some defense in task 2, and we will do some cross evaluation on this, and you can try to find a reason why the adversary examples generated by team 2 can fool the defense that built by team 3, something like that. You just try to find the reason. And yeah, I think that's pretty much it is. And I will add something on the report. Yeah, so write the report, try to write the report in a scientific way. I think the formalized definition and notations will help you to do that. Yeah, is there any further questions? Am I lost? Any questions regarding the project? Okay. Could you hear me?
Yep.
Okay, thank you.
Pretty clear. Yeah, it's just pretty clear to me, I think.
Okay, great. So if you have any further questions, because currently we just went through this very far, very quick. So if you and later you have something you don't understand, you can just open an issue here. Any questions or any problems regarding the project, we can new an issue here, and you can assign to me. For example, here, assignee, you can assign to me, so I can get the notice, and I will try to reply as soon as possible. Okay.
Actually, we don't have the option to assign issues since we're not part of the repository.
Oh, okay. Then that's fine. I will check it every night. Okay. I will check this every night. If there are any unsolved issue, I will answer that. Okay.
What I originally did was I used like @yingmeng to make sure the notification went through. So I think that would also be helpful for anyone.
Yeah, but since I might have some other stuff to do in day, so I will check the issues, check the piazza every night. So I will answer all the questions within 24 hours.
Sure.
Yeah, thank you. So yeah, the code has been uploaded, has been pushed here. You can get the code from this, and here is the requirements. So this project was based on PyTorch. So you simply install Anaconda with PyTorch, and then here is the requirements. Then install all the libraries here. So I think it should be good. Let me get this. Oh, okay, here. So here are this folder. In this folder, I will put all the documents in here. So could you recognize this? Is it too small? I mean, I'm not sure.
That seems just barely big enough. I can read it as well.
I'm sorry, I could not hear you.
I said that seems big enough.
Oh, it's too small, right? Okay, let me try to. How about now?
Yeah, that's good, I think.
Yeah, that
Okay.
seems fine.
Okay, thank you. I don't think I can enlarge this. Let's check this in here. Okay. Okay. So all the source code will be under this folder. So in here we have, I will put some tutorial in this folder. So later you can check it out. So we have some folders, the utils, the utilities will be put in here. For example, here for data, I will. Maybe you don't need this at all. I mean, in this project, because these functions are for the C500. If you are not using C500, you don't need this at all. And the file here, I try to implement some I/O operations. So I will read a list from a text file for you and load a dictionary from JSON and dump a dictionary to a JSON. And I can also save a dictionary to a CSV file. Also, we can load from CSV to a direction. Yes, sorry. Metrics. So here, I think basically this one, in here I provide this method help you to compute the error rate, because for the adversarial examples and your defenses, you always need to evaluate your approaches and your AEs. So this one will help you to do that. Model. Yeah, so here, this method will help you to load a pool. So, and this just load a single model, a single CNN model. This was for the vanilla version of Athena. So it will load a CNN. I will add one. I will add one more to load SVM, because in here you can choose to wrap the. For example, the CNN I provided actually was trained, was implemented in Keras, but later we moved from TensorFlow to PyTorch. That's why we provide a wrapper to wrap that model. So we don't have to retrain a model use PyTorch. So we wrap the TensorFlow model to a PyTorch model. Later, I will provide another API to wrap SVM to the one we to the one we supported here, and transformation configurations here. So here, basically, we define some. So for each type of transformation, the tunable parameters and some subtypes will be defined here. For example, for the denoise transformations, we support wavelet and in something else. For the noise transformations, we support Gaussian, poison, salt, pepper, something like that. And this one defines the category, the highest level category of the transformations we supported here. Yeah, models. So this one may be the most important part here. So the keywords here, this is the wrapper to wrap a TensorFlow or keras model to a weak defenses we support. So if you train a weak defenses, use the keras. When you want to load that model, to use that model as the weak defense in your ensemble, you need to wrap it using this method. And this is for the PyTorch. If your model was trained using a PyTorch, so you need to call the weak defenses we defined here. And this Athena, we defined the ensemble model here. So yes, so you need to provide where's the int? Yeah, so you need to provide a list of classifiers. So these are the weak defenses and the strategies you are using. The strategies we defined it in here. So you can call this ensemble strategy. For example, you are using majority voting. So ensemble strategy dot mv dot value, something like that. Okay, I think so the most important two parameters are here. You must provide a list of classifiers. So here the classifiers must be the weak defenses. We defined it here. So you must convert it using this weak defense or the one defined in the PyTorch. Then so maybe so here the wrapper for the weak defenses, you need to provide the model you wanted to wrap. You want to convert and the transformation configurations here. I will show you how to define this configuration. So in this configuration, you will define the type of the transformation type and some tunable parameters. And if you want to use logics, make it true. Then for the rest, you can just keep them as the default value. So after you convert your weak defenses, you can build your ensemble. So these classifiers must be either the keras or PyTorch we provided. So you need to provide a list of classifiers. You need to provide the strategies you wanted to use. And here this classifier weights. Classifier weights, this is for you to do the extension. So currently we just use equally weights for Athena. So when you learned some weights use another approaches, you can fit the weights here. This weight is actually a vector of a vector of weights. It's just like a vector of the probabilities you get. So if it's none, if you are using Athena, the vanilla version of Athena, you just keep it none. Then we will make it equally weight here. Yeah, if you have any question, you can ask. But if you cannot you cannot ask any questions right now, you can ask questions later after you check the codes. You might have some thoughts. So this image processor, we implement the transformations here. So all the transformations will be implemented here. Rotations, translations, flipping, and others. So whenever you call this function, here, this is the entrance. So when you call this, when you wanted to apply transformation, you just call this transform. This is the data you wanted to transform the images, and here this should be the transformation arguments. So this actually the transform configurations. I will show you the configurations later. Okay. Oh, there's one very important things here. In Athena, all the images will be scaled in between 0 and 1. So the pixel values should be in 0 and 1. I know some of them may use 0 and 255, but we scale to 0 and 1. So here we define the models. Here we define the attacks. Yeah, so here we define the attacks we supported here. The other APIs, you will not use the other APIs in this project. So this one you might want to use just to track what type of attack we supported. And the attack. So the main entrance is the generate. To call this function, you need to provide the model. So this is the target model. You wanted to generate the adversarial examples based on this model. So the data, the data loader actually is a tuple, consists of the images and the true labels. And here are the configuration for the tunable parameters for each attack and the device. If you have GPU or something, you can specify this to GPU. So this is the entrance for the attack. You only need to call this function.
Question for that
yes.
model that model we pass in. Would that be one of the weak defenses, like, or a model wrapped in one of those weak defense, or?
Yeah. Yes. Right.
Okay. Yeah.
Thank you for asking. Yeah, that's a good question. So this model, since I have implemented the ensemble for you, so in here for this attack, there's no difference between a single model and an ensemble. So this model can be a single weak defenses here, a single weak defense here, or an ensemble. But you must have to define as an ensemble class. Okay, this configurations will also be defined in a configuration file. I will show you later. So these are the attacks. anything. So the scripts, usually I just put the scripts for my experiments in this folder. So for example, when you need to train a model, or you need to generate some adversarial examples, something like that, everything regarding the experiments. So the configurations, yeah. Here I will put the configuration file. So here in this experiment, these three configurations are the configurations we defined for Athena. So basically, when you get this this file, you will get the vanilla version of Athena, because each weak defenses each weak defense is associated to one transformation. So you will define the transformations here. So the first one here, 0, is the clean model, is the undefended model in Athena. And the rest of them will be the 72 weak defenses for MNIST. So you can see here, if you we have some weak defense associated to rotate, and this one I simply use this one. I mean, for description, describe this type of transformation, and you can utilize this, for example, as when you name the trained model or something like that. So this is customized. And this, so for a rotation, we need one parameter, angle. So rotate 90 degrees, rotate 180 degrees, something like that. So for translate transformation, it requires the offsets. So offsets in X or offsets in Y. So this just the name you give it. It won't be used in anywhere. I just use it for the name of the trained models. So you can see here. So different type of transformation will require different parameters. So, yeah. So here are the other values for the vanilla, for the weak defenses in vanilla Athena. And here is the data. So the data in this JSON file, I define all the adversarial examples we generated. So all of them will be located in this folder, and the benign sample is this one, and the true label will be this one, and the rest will be the adversarial examples we provided. I think in total there are 45 of them. So when you evaluate your defenses, you don't have to evaluate, 45 of them. You just choose maybe 1 or 2 from each type. You can see for FGSM, we have different epsilons here. For this BIM L2 norm, we have different orders of different epsilons here. You just choose 1 or 2. That's fine, because it will take time. And yeah. And this model, yes. So here, this one just helped me to define define the model for the names when I load the model, load a pool. So this just helped me to define, for example, the prefix of this model name, the postfix, and then here I will connect the transformation description. And here is the location for all the models. So that's it. Here I have, since we have 72, 73 weak defenses there, I define a smaller subset here. So for you can use this as a demo or for debugging, something like that. You can even make this even smaller. Yes, I think that's pretty much it is. Let me show you some code tutorial. So in this tutorial, I just test the transformations. So it will require some parameters, the transformations. The hardware, I don't think it has any, I think basically currently, for MNIST, it doesn't have much, it doesn't have a high requirement on the hardware. So I think maybe, I think all of your desktop or laptop should work. It should work fine on your computers. But C400, that's a different story. Okay, so to run this program, you need to provide a transformation configurations. So for example, here the Athena MNIST, and you need to provide the model configurations. We just show you that it's the model. So in here, it just defines the location of the models and the prefix of the model names and the postfix of the model names. And here the data. Here are the where the test data locates, and the names of the test data. So it will require an output for the experiment results. And I also provide something like the mode. So if it's in debug mode, it will try even smaller subset. For example, we have 10 cases in the test data. In this debug mode, I might only try like 10 samples. Okay, so after you get those, you will load the configurations. You can call this function load from JSON, and it will prepare these configurations for you, and then here, so we can load a pool. Load the data, and then you can call this transform. It will transform the data for you. And then even in this debug mode, you can plot the figure to see how it looks. I think maybe, it's time? I think it's time, right?
You can, if you need more time, definitely feel free to continue. Better to finish it today Or if
Okay.
you feel that you need more time, and
Yeah, I guess
other
just five more minutes. Yeah. Okay.
Absolutely.
Yeah. So this is the example to generate adversarial examples. So after you load the pool, the weak defenses. So the first one is the undefended model. You can get it and pop out from your pool because this is not a weak defense. And then you can build an ensemble model, use the weak defenses, use all of the weak defenses, and you need to specify strategy. So here I use adversarial probability, and then here is the attack. Yeah, so the attack, the configuration, here is the example of the attack. So here, basically you need to define the type. You need to provide the value of, because this is an FGSM, you need to provide this epsilon. You can also provide the batch size if you want, but this is not necessary. Batch size is not necessary. Only this epsilon. Then here, this is the entrance of this attack. So we simply call this function generate. If you want to generate examples in the context of zero knowledge flat model, you use the undefended model as the target model. If you want to generate adversarial examples in the context of white box flat model, you simply use this ensemble model as your target model. So simple as that. So basically, I have shown you how to do your task 1 and the option 1 of task 2. So basically, you simply change this this undefended model to an ensemble model. You just done your task 2. So that's it. So that's it. That's I think that's the how to, yeah, I think that's the main points I wanted to show you about this Athena. I will provide some tutorial on the GitHub, so you can check it out, and maybe you can download the source code and play on your computer. Then you will get more familiar with it.
Yeah, thanks, Ying. That was excellent. So as you can see, your project, your task would be really easy, right?
Yes.
But we expect you guys to do some creative work. We are really looking forward you to go beyond the expectation and do some, amazing work, learn something new, and try to come up with some very interesting either attack scenarios or defense or any extension, hopefully, of Athena. So we are very much looking forward these, surprises. Like if you could surprise us, that would be an excellent sign. So we are really looking forward to these surprises. Do you guys have any questions? We are here and happy to answer yours.
Yeah, you can also ask questions on GitHub or Piazza. That's fine. Yeah, if you think you need more time to get familiar with this stuff, and then maybe you will have question later.
Yeah, definitely. Again, to emphasize, and this is quite important, right? Please really pay special attention. The way how you need to deliver your code, report, and everything. Once you announce your team through the follow-up issue that you already see in this repo, then we will add your GitHub account, and all of you need to have GitHub account, right? So there's no excuse. You can create free GitHub account, and like the way how Cody added his team, you do follow the same list of people with the associated GitHub account. Will add you to the organization, and then you will be able to create your own repo, and that's the first step, right? You want to have one repo with proper name, like whatever name you want to come up with, and try to push your code, your update as frequent as possible to these people, okay? This is also helpful for facilitating collaboration between you guys, right? You don't want to share the code via email or something. Like everything should be on GitHub. That's what we prefer. And don't worry, like we don't look at like your code unless you tell us. Don't worry that your work is not complete. We don't look at it, and we don't evaluate it unless you tell us. So don't worry about that aspect. Try to use this platform for communication. You can also use like issue tracking for within your own GitHub GitHub repo. For example, for the activity you plan to do. You can
actually you can also actually you can also utilize this projects to manage your project. This one will help you to track. You can see here, you can track the changes. You can even define the milestone or something like that.
This is thanks for mentioning it. This is excellent. Use this new feature of GitHub. This is something quite useful.
You can assign. You can connect the issues with some tasks in your project. So when you're, for example, when some task has been done, it will close that issue for you and move to the next stage of this. So you can try it. It's fun.
Yeah, it is. We are really looking forward you guys to work really hard for this project, because it's going to be useful for your understanding of machine learning systems. And this is, as you know, it's one of the most exciting and hot topic in machine learning, and going to be very useful, especially the key reason that we emphasized on machine learning, adversarial machine learning, is that this is going to be useful for systems, future systems that will be out there soon. Already they are out there, right? So it's for a key reason, good reason.
Yeah. How about just for the one last thing I wanted to update. So for this task 2 option 1, since you just see that you don't have to do anything, then you can get all the things done. So I wanted to allow all the groups to select this. So I will encourage you to do some other stuff first. This is just a plan B. If you cannot work out, for example, if you I mean in the last week, you still cannot get the new approaches done, maybe you can simply generate some AEs we provided and do the analyze, something like that. So you don't have to worry about your credits, and you can try new things in the first 2 weeks, something like this. How about this?
Yeah, that's a good idea.
Yeah.
Yeah, and we are open to any suggestion, right? If
Yeah.
the suggestion would be useful for you guys and would be fair for all of you. So if you have any useful suggestion for making any changes that you think would be useful and fair and helpful to this project description, okay? Maybe think less about the percentage of the score and grades. Don't
Yeah.
think about grades at all, right? As long as you do great work, don't worry about your grade. This is the last thing you should be worried about. Focus on interesting surprises work. But if you do have any suggestion that could improve this project description, this is really would be helpful, especially at this stage, right?
Yes.
If you do have any suggestion that would clarify things, please create an issue and suggest yours. That would be useful for us, and we would really appreciate it.
Yes, since this is the first time we are doing this, so you will help us to develop this class.
Yeah.
This course, yeah. Thank you. So I don't have any comments.
Great. Thank you, Ying. It was excellent. You're awesome.
Thank you.
I did have one question.
Yeah, sure.
Yeah, so do you want me to put the preferences for task 2? Would you prefer them in Piazza, or would you prefer them in the team formation request on GitHub?
In team formation. Everything in team formation, or any other issues there, right?
Cool.
So yeah, because we would like Piazza to be mainly for communication, but not for, keeping track of the project. Everything about the project should be on GitHub.
Yes, we prefer everything regarding this project on GitHub. You just new issues. Thank you. So we can track this and we can improve this project next time.
Yeah.
Thank you.
So
thank you.
If there's no question, so thank you. It was great to see you again. So looking forward to this, and have a good weekend.
Yeah.
Thank you. Yeah, you guys have a good weekend.
Bye.
Thank you too. Bye.